Hey guys, welcome to Lecture 6 for Intro to Backend Development. Today we're going to be talking about deployment, which is a critical skill to have if you're a backend engineer, because otherwise you'd create all these amazing functionalities and features for your server, and then no one would be able to use them. So let's first go through some review. Last week we talked about containerization, basically packaging code into a standardized unit of software so that we can run the code basically the same way as we do locally as we do in another machine. So what we do is build code into images, we run images in containers, and we can also push our images to Docker Hub so that we can access these images elsewhere. All right, so we've been talking a lot about servers. We've been building servers, we've been coding servers, but what really is a server here? We talked a little bit about, what is a server before in terms of like clients versus servers, but let's talk a little bit about like networking. So first, let's kind of remember what server is. Remember that a server is essentially just a computer, but more abstractly, we can think of it as a software or hardware device. Essentially anything that really like accepts and responds to requests made over a network. So let's talk about a few examples of servers. One thing that we've been working on are like web servers, right? So we run apps through web browsers, and occasionally we can serve pages. And what would the client be in this case? It would be something like a web browser, like Firefox, Google Chrome, that's making requests to the web servers so that they can load your pages. Another example is an email server. So a server that's literally just handling email, sort of like the Gmail servers. So these manage sending and receiving emails. And you can imagine the clients for this would be something like our web browsers, if you go to like gmail.com, or even one of your apps on your phone. If you're thinking mobile, you can have an iOS mail app that's accessing an email server. We also have something called like identity servers. So you can think of these as authentication servers. Essentially, they manage login and security roles. So if you've ever tried to log into Student Center, you'll realize that you're going to make a stop at CU Web login first. It's going to ask you for your like net ID and password, and then probably like Duo push with two-factor authentication. So what we're doing here is that the browser, you're going to give your credentials to the browser. The browser is going to redirect you to CU Web Login. And then from there, your credentials are going to be passed into CU Web Login, and they're going to authenticate you and either give you access to Student Center or deny you access so that you can't log in. This is really useful, right? Okay, so let's talk about servers and the network. The network is very nebulous, and you've probably heard about some of the terms that we're going to talk about, but we're going to briefly go over them so that we can kind of clear up, what exactly are these things. So an internet server is assigned an IP address. Just like a real address, this address is going to separate this internet server from, literally all the other hundreds of thousands of million servers, just like your house address is going to separate your house from every other house. And so this IP address, again, distinguishes the server from others on the network when it connects to a router. So what is a router? One of the most common ones is the Wi-Fi router, which is like the wireless router. So users connect to a server by its domain name. So you can think of them as sort of a more readable version of IP addresses, right? Domain names are translated to IP addresses. So when you go to, domain like google.com, what's actually happening is that a DNS resolver, so domain name system resolver, which is another kind of server, will take the domain name you typed in, and then it's going to be like, oh, this domain will actually translate to the IP address of like 321.72 dot whatever, right? You've probably seen something like that, like your local host, maybe 127.0.0.1. And that's how you are able to sort of reroute your requests to the correct server. Okay, so let's talk about deployment. So why would we deploy something when we can just run them on our computer? I guess that question sort of answers itself, right? So what exactly do we need our new app to do? First, our app needs to always be running, right? Imagine if like your app was only running when you were on your computer, and maybe your app is something like Facebook. Wouldn't it be really annoying if your if your Facebook app was only accessible, whenever, I guess, Mark Zuckerberg's computer was on? No, it needs to be up and running all the time, 24/7. Second, it needs to be open to receiving requests. Third, it needs to be publicly accessible on the web. And fourth, and one of the most important things for us and our purposes at least, is that our app needs to be hosted on, our server needs to be hosted on hardware that's managed for us and connected to the cloud. So essentially what we're doing here is, instead of, running our app on our dinky little computer, who knows, I don't know, like 2014 MacBook Air, we are going to be borrowing or paying for some hardware that's owned by another company, maybe like Google or Amazon, and that hardware is going to be managed for us, and it's going to be hosted remotely. So what's really nice about that is that, if their computer breaks, that's their problem. It's not our problem. And they're also going to handle a whole bunch of other stuff: authentication, scalability, security, all that kind of stuff that would be quite, a pain for us to manage by ourselves. But, if you get these big tech companies on it, they will probably do a better job than, your average student. So to elaborate more on that fourth point, we want to run our application on a server in the cloud. And we do that by renting a server. So we're going to run our containerized software just like we do locally, which is why doing containerization is so important, because we want to make sure that our software is going to run exactly the same on our rented server in the cloud as, sort of like on our own computer. So we will allow the server to be managed by a cloud service, which again, they can handle the physical maintenance, and they provide tools to automate all sorts of things, especially crashes. If a server crashes, they can automatically bring it up. So you don't have to wait until someone on Reddit posts like, hey, this person's app is broken. Hopefully, any blips you have in your server will just sort of be sorted out by this cloud service. So here are a couple of examples. You've probably heard about a few of these, maybe Google Cloud, Amazon Web Services, which is one of the biggest cloud services, Microsoft Azure, and DigitalOcean, which is actually what Aptiv uses to host its servers. For our assignment, we will actually be using Heroku, which is another cloud platform. And it's really nice because that one is free for us. Okay, so how do we actually access a server? We use something called Secure Shell Network Protocol, which we can shorten to SSH. So computers are always talking to each other, and we need a way to talk to each other securely. So SSH, as its name might imply, just gives users a secure way to access a computer. You can think about, it as communication between a host, which is the remote server we're trying to access, and a client, which is us. So why would you ever want to access a computer? I don't know. There's a lot of reasons why you would actually want to do that. One of the first reasons is maybe you want to open and view some resources you have on the remote server. You want to execute some commands on the remote server. And often what we would be doing is installing, packages, like if we need to update a package version or update our own software on the remote server. So very, very useful. And that means you don't have to walk all the way to Amazon headquarters to try to get into your remote server. That would be ridiculous. So what exactly does SSHing look like? Again, secure shell. So you're going to be doing this in your terminal. And to actually log in to your remote server, you can run the following command, and here's an example. So here we have ssh-i server.pem aptiv@eaterybackend.cornellaptiv.com. So you can probably see here that what we're doing is that we're trying to SSH into our backend server for our app eatery. And let's break this down a bit. So the -i flag stands for, you're going to be passing in an identification file. So this is, you can think of it as your credentials to log in or access the server that you're trying to. And server.pem is an encrypted identity file. It's essentially a certificate that says that is encrypted. So, all the sensitive information is protected, and it'll, what you have on your own computer is a public key, right? So you have two types of keys. You have your public keys and your private keys. And the public key is going to be available to you. And the private key is going to be available only to our remote host, which is Eatery Backend. So you're going to have your unique public key that's been generated, and then you're going to pass it along when you SSH. And the host will check it with its private key. And if certificate looks good to go, then you're able to SSH into the server. You can see here, eaterybackend.cornellappdev.com is our domain here, which is going to map to the IP address of the server we want to access. And once you manage to get in, you can take a look. You have access to the remote server's command prompt, and you can do anything you want. So again, what we're doing here for SSH, security is a big thing. We provide our username and password credentials. And then we also have our unique public key pair that allows us to authenticate the local to remote, as well as the authentication of remote to local. And again, the host will have our private key pair that we can have to automate login. So what does this look like? Again, here's our command SSH user@server.com. And actually, you'll be prompted with the server's key and request to connect. And if you've not connected before, essentially your computer has a running list called known hosts of all the servers that you've connected to before. So once you have successfully connected to a server, that server is going to be added to the known hosts, and you can automate connection again next time you visit that server. So you are authenticated via public and private keys and credentials. And again, if you're successful, you will be able to open the command prompt of the remote server. Okay, so enough about SSH. We will actually not be using SSH in our assignment 6, essentially because we realized that Heroku is actually very, very easy to deploy servers with, and it's really convenient. And you know what? We support convenient things. They help you develop with speed, so we're going to go with Heroku. And SSH is very useful, though. If you haven't used it already, you will definitely use it in the future. So if you have any questions about that, make sure to ask on Piazza, and we will answer your questions to the best of our abilities. Okay, so let's talk about how we can optimize our servers, because there's a lot you can do once you go outside of the boundaries of just hosting your server on your own local computer. And now you have access to other people's hardware, and you can use remote servers. So the first thing we're going to be talking about is clustering. So here's the overview. Essentially, a group of servers is connected to behave as one system. So you have multiple servers instead of just one. And each server is optimized for a particular purpose. So instead of having one server that does it all, maybe now we have a couple servers, and each server has its own functionality and its own purpose that it does really efficiently and very quickly. And when you integrate it all together, so all these servers can communicate with each other, now our system is a lot more efficient than it was before. So we just get a better performing system. So what does this look like? Say we had a server before, and it was hosting a web application. It also had a file storage system on it and a database, which is fine. But what we can do instead is now distribute these functionalities among multiple servers. So server 1 is hosting only the web application, and server 2 handles only file storage, server 3 only the database. And now we have a lot more hardware. We have a lot more processing power per functionality. And if the servers are able to communicate efficiently, now you have this great system that will not only be more scalable than what it was before, because you only had literally one server that did everything. You also have something that is good if something fails, right? Because if that one server before failed, then now all of your functionality is down. But if maybe only server 3 is down, then okay, you lose access to your database, but at least your web application is still up and your file storage is still okay. So benefits, we have backups and crash handling, and we have something called resiliency, meaning that like if bad things happen, not everything goes down, just like what we said before with data resiliency and application resiliency. We also have systems management. So again, this is more along the lines of, how is your system being integrated? How are we sort of sorting out functionality between the servers? And then finally, we have scalability and load balancing. And we're going to be talking about load balancing, actually, because this is a really interesting idea. So now instead of saying maybe we have like 3 servers that have 3 different functionalities, what if we had 3 servers that did the exact same thing? So we have like 3 copies of this web app 1. So we have web app 1, 2, and 3. And they behave the same way. So what we can now do is we can have another server called a load balancer server, and that will take incoming network traffic and redistribute it over these 3 servers. So now sort of their workload is, split by a factor of 3. And this is really nice because imagine like the biggest apps you've ever used, like if you're on Google or Facebook, there's no way that only one server is handling all of the traffic that goes to Google, right? Like people are making probably millions of searches like every minute. If one server, you'd have to have like a crazy supercomputer to handle that. So Google definitely has a bunch of servers and definitely has a load balancer to make sure that network traffic is redistributed evenly through all of these servers, so that if web app 1 is getting a lot of traffic, then now you can start redirecting it to another one. So yep, we have network traffic going in, and we can distribute it to web app 1, 2, or 3. And if we have a ton of network traffic, so this is a really nice thing about load balancing. So now say, it's election night and a bunch of people are going to the NewYorkTimes.com to check out, what's happening with the polls and whatnot. So usually the New York Times doesn't get that much traffic, at one instance. So they didn't need to have like a million servers hosting the web app. But maybe you say their systems management realizes, oh no, we definitely need more servers to handle all of these incoming requests. Let's just spin up 2 more servers that are copies of the web app. And now the load balancer can distribute it to the additional servers. So this is really, really good for scalability. And definitely if you make a popular app, which I'm sure you guys will, you're going to need to know something like load balancing. So yes, that was our lecture for this week. And hope you have fun with deploying your apps.